When most histories of the Korean War are written, the focus falls on troop movements, firepower, and political stalemate. What rarely makes it into popular accounts is the impact of simple construction choices on soldier survival, operational efficiency, and even long-term military strategy. One such overlooked detail is the orientation of wood grain in field structures. Old carpenters, in Korea and elsewhere, followed what could be called a grain direction law, instinctively understanding that the direction of growth in timber determines strength, flexibility, and longevity. Modern builders, whether due to expedience, standardization, or unfamiliarity, often ignore this principle, a decision that, in the harsh Korean climate, had tangible consequences for shelters, observation posts, and supply depots. The Korean climate exposed every weakness in improperly oriented timber. The Korean peninsula is deceptively harsh. Summers are humid, winters can drop far below freezing, and frequent rainfall, coupled with rapid seasonal shifts, puts immense stress on wooden structures. Soldiers in forward positions relied on quickly assembled barracks, observation posts, and supply sheds made from pine, fir, and other local softwoods. These woods are easy to source and work with, but they expand, contract, and warp according to the orientation of the grain. Forward posts constructed with grain running perpendicular to stress points, something traditional carpenters avoided, quickly became unstable. Roofs sagged, floorboards warped, and walls bowed under minor snow or wind loads. Field reports from late 1951 indicate that some observation posts required daily reinforcement simply to remain functional. These were not catastrophic failures, but small structural compromises that forced soldiers to divert attention from patrols, logistics, and tactical readiness to maintenance. Old carpenters understood grain direction as a matter of survival. Historical carpenters did not treat grain direction as aesthetic, they treated it as a law. Timber expands most across the grain and less along it. Old builders knew that laying floorboards perpendicular to joists, orienting beams with the load along the grain, and aligning planks to shed water properly could extend the life of a structure by years. In Korea, some experienced carpenters embedded in engineering units attempted to apply these lessons. Posts built with proper grain orientation, even when using the same softwoods and subjected to the same environmental extremes, retained structural integrity for the duration of a campaign. Observation logs and post-war analyses note that posts with correctly oriented timber required significantly fewer repairs and supported heavier loads. These successes were exceptions, however, because speed and manpower constraints often took precedence over craftsmanship. Modern builders still ignore the lessons of grain direction. In contemporary construction, standardization and reliance on fasteners often replace an understanding of how wood naturally behaves. Prefabricated lumber, plywood, and engineered composites can mask grain orientation, and speed-driven methods overlook the nuanced decisions that carpenters historically made. The lessons from Korea remind us that ignoring grain direction has real-world consequences. Even minor mistakes, like floorboards laid across joists without consideration for expansion, beams oriented incorrectly relative to stress, or siding attached without accounting for seasonal movement, accelerate wear, warp, and decay. The result is what soldiers in Korea faced: daily structures that require constant labor to maintain, reducing operational efficiency and, in extreme conditions, threatening survival. Structural decisions directly affected soldier endurance. The decay and warping of wood structures were not merely inconvenient, they had immediate effects on the men living in them. Floors that warped in winter created trip hazards, while sagging roofs allowed wind and snow to enter, increasing exposure to frost and illness. Supply depots stored ammunition and rations, and improperly oriented wood accelerated rot. sometimes rendering these materials unusable. Diaries from the 1st Cavalry Division describe soldiers spending hours shoring up minor warping and broken boards, hours that could have been devoted to reconnaissance, maintenance of defensive works, or rest. The indirect effects were even more significant. Soldiers exposed to moisture and cold experienced higher rates of frostbite, illness, and fatigue. Maintenance cycles consumed energy and morale. The consequences of something as subtle as grain direction were cumulative, demonstrating that survival in harsh environments depends as much on small technical decisions as on strategy or tactics. Grain orientation influenced load-bearing and combat function. In forward observation posts, structural strength was crucial. Improper grain alignment reduced the load-bearing capacity of posts, affecting not only the shelter itself, but the tactical functionality. A poorly constructed observation platform might not support a heavy periscope, radio equipment, or even a small team of men. Historical field experiments from the United States Army Corps of Engineers document that posts built with grain aligned along stress vectors retained upwards of 90% of their load capacity after months of exposure, whereas incorrectly oriented posts lost nearly half their strength. The difference wasn't dramatic in one day, but over weeks it determined whether a post remained safe and operational. Climate, material and labor combined to create hidden hazards. Softwoods harvested locally were often green and improperly seasoned. Paired with hurried assembly and disregard for grain direction, structures became prone to warping, cracking, and premature decay. Soldiers improvised, adding shoring, sandbags, or temporary supports, but these measures were labor-intensive and imperfect. Field reports from Central Korea in 1951 described the repeated rebuilding of temporary shelters, a direct result of ignoring these basic material principles. Even when soldiers applied coatings such as linseed oil or light paint, the structural weakness introduced by poor grain orientation undermined the protection these treatments offered. It was not a matter of insufficient materials or lack of knowledge alone. It was the combination of environment, human urgency, and the failure to respect the natural properties of wood. These lessons shaped post-war military construction. Post-war evaluations incorporated lessons learned about timber selection, grain orientation, and protective treatments. Military manuals began emphasizing elevated flooring to prevent moisture damage, proper alignment of structural members to match grain direction, and pre-treatment of key load-bearing timbers. These changes were implemented not only in permanent bases, but also in disaster relief and reconstruction projects, demonstrating that operational failures can inform broader civil and military engineering standards. Understanding grain orientation reveals broader patterns of human endurance. The story of wood grain in Korea is not simply about carpentry, it is about human resilience under challenging conditions. Soldiers' ability to endure relied on engineers making informed decisions about material behavior. A misaligned beam or floorboard did not merely warp, it shifted energy from fighting, patrolling, or resting into maintenance, increasing fatigue and exposure. Proper attention to these small details enhanced both structural durability and human endurance. The Korean War illustrates a wider principle. Attention to material properties and traditional craft methods often determines the difference between temporary comfort and sustained survival. Commanders often prioritize speed and apparent efficiency over durability, with consequences that ripple across months of campaign operations. Modern builders and survivalists can learn from historical practice. These historical lessons are relevant beyond military history. Survivalists, engineers, and builders in challenging environments must consider load distribution, timber selection, and grain orientation. Structures built without attention to these factors will require constant maintenance or fail prematurely. The Korean War offers clear evidence that careful, deliberate construction, even in adverse conditions, pays dividends in endurance, safety, and operational success. Remembering these lessons matters for both history and practice. The grain direction law is not a relic of the past. It is a practical insight into survival, structural integrity, and human endurance. Korean War structures illustrate what happens when expediency overrides material knowledge. By studying these examples, we gain insight into both history and practical engineering, lessons that are relevant for modern construction, survival preparedness, and understanding the lived experience of soldiers. If you value detailed, contextual history that goes beyond battles and politics, subscribe to History Matters. Share this video with others who want to understand the subtleties of engineering, survival, and human endurance in wartime conditions. The grain direction law may seem minor, but it reflects centuries of practical knowledge that shaped both past survival and lessons we can apply today. History is not only in events, it is in the decisions, techniques, and small, often overlooked principles that determine outcomes for both structures and the people who depend on them.